Hello everyone, thank you for being this present. My name is Kukheon from Digital Project Research Center at Korea University. It is an honor and pleasure to present. Thank you to the DFRWS committee for letting me be here. My presentation is Yuka is recording. Today I talk about analysis for dashcam. Everybody knows dashcam. Dashcam as an onboard camera is recording 24 hours and 7 days. It is also called car black box, car digital video recorder, and event data recorder. The dashcam is a moving surveillance camera, so that is useful as a source of potential digital evidence. The dashcam stores variety of additional information in the storage device. We know that additional information is metadata. Metadata is a useful resource for analysis in digital forensic. Next, let's talk about motivation for our research. Nowadays, the dashcam is an essential element of the vehicles according to related law and regulations. For example, in the US, commercial vehicles such as police cars, buses, and taxis installed to comply with commercial motor vehicle safety law. And private vehicles like Uber and Lyft use it to prepare evidence of accident investigation and resolve dispute on insurance claims. In Korea, if installed a dashcam, then insurance company offers a discount on insurance rate. So for this reason, market analytics predict that the global dashcam market is expected to register compound annual growth rate of 15.4%. And I already said the dashcam is useful as a source of digital evidence, not only to reveal the truth of a traffic accident, but also to explain the situation of a crime scene as a moving debris. In general, dashcam stores proprietary multimedia data in a removable storage device, such as SD card and micro SD card. Major manufacturers usually provide a dedicated viewer, so examiners to analyze visual data along with non-visual information, including time, location, and speed, and etc. But they may have difficulty in responding to issues, such as bankruptcy of manufacturer and corruption of files using proprietary format. Under this circumstance, various studies have been conducted for dashcam forensic, but most of them focus mainly on extracting, recovering, and visual frames. In other words, existing research cannot analyze non-visual metadata. So we identify and classify various metadata within 14 dashcam device. We have to know basic operations of dashcam. First, data storage, which mainly use flash memory, and nowadays dashcams are connected to the cloud that can be uploaded multimedia file via LTE or 5G. Second, file management. Dashcams usually delete the oldest multimedia file before creating new one when its storage device is full. Third, dashcams support various recording modes. Basically, there are two modes, normal and parking. It is based on whether start ends on the beacon. There is also event mode for recording when a shock is detected from 3-axis sensor. Also, manual mode can be used to begin recording manually whenever user needed. A multimedia container format is used to store multiple objects in a single file, such as video, audio subtitles, and location. Digital video device use a codec for efficient compression. The popular standards of codec for dashcams are H.264 and H.265. This figure shows the structure of H.264. And also that is stored standard or proprietary data, like speed and location. MP4 and AVI are the most popular file format to handle multimedia data. The left is MP4 file format. The right is an example of AVI file format. Both formats store multiple types of data using a specific unit that is called chunk. In general, multiple chunks have a hierarchical structure for managing different types of data, and each chunk consists of type and size and data pair. We considered the following factors to select an experiment device: release data, substitute file system, multimedia file format, recording mode, number of camera channels, watermark text. As a result, we selected 14 dashcams from 11 manufacturers and created experimental data set. This table presents detailed information of selected models. We identified 22 meaningful information through a systematic analysis of dashcam storage device. Dashcam was storing many metadata types, so we classified it and represent the metadata. That is 7 main levels we called level 1, and 21 sub-levels it called level 2. And level 1 is consists of container, device, location, recording mode, status, and time, user preference. And also we using the defined abbreviation. R is recording mode, EV is event mode. This figure is a summary of the metadata what we found. Gray box is source where the metadata is located. White wave is type of metadata. And blue box is time information. Next, we explain the result of our brief analysis because time is. Let's take a look at the result of our analysis. First, file system analysis. As target models of FAT32 and EXFAT file system, it is possible to get useful metadata from directory entities of FAT. First, directory hierarchy. Examine us to identify specific recording modes and data of relating to the container files. That is recording mode, and is this a create date? Second, file naming rules. Each dashcam model uses a set of rules to assign names to the files. In this figure, this is created time, and this is recording mode. E is event, I is normal, M is manual in this scenario. And this is camera channel. 1 is video of front, 2 is video of front and rear view. Third, other considerations. Timestamps stored in PET file system entries. It will be useful for forensic purposes. For example, of creation timestamps can be used as a factor to determine whether a file was normally created by a dashcam or copied from an external system. Moreover, due to the nature of 24 hours and 7-day operation, multimedia files are frequently created and deleted in a storage device. So examiners need to consider carving process for registered data. Next, the operating system and application file analysis part. It is consists of multimedia files and other files. Multimedia container formats store multiple types of data using a specific unit, unique chunk names, and chunk sequence. That is possibility to identify a specific dashcam model in our experiment, or MP4 format generate unique chunk sequence. But several models difficult to distinguish between individual models. So these container formats can be represented as shown in this figure. Look at the figure on the right. Can you distinguish in this figure? Answer is yes. The chunk structure of the file is different, so you can distinguish it. Meta chunks may include meaningful information, like a timestamp, resolution, number of frames. In the MP4 containers, the meta chunk is movie header, track header, and media header. In the AVI containers, AVI header and stream header, stream format chunks, and info. And also see detailed descriptions in the right figure. The video codecs basically store information for decoding, such as frame per second and resolution. In AVI container codec storing this chunk with compressed video data by codec. But MP4 container separately store decoding information in AVC1 or HVC1 chunk. Specific model generated SAI NAT in video stream. The first 4 bytes are the name of chunk, and next 4 bytes is size and data area. In data area, it is H26 for start words for distinguished from random data. And next 1 byte is null type. In this case, 6 is SAI null header. Also, following data is metadata, time, location, and status data. You've seen the watermarks in the video. It is possible to obtain video frames by decoding a set of ideal and non-ideal lives with the above-mentioned video stream. As a result of analysis on the decoded video frames, we confirm that all 14 models insert the information, including time, status, device, and user preference. Most of target models create a customized subtitle to store metadata, such as time, location, and status. It does not follow the standard subtitle format. That means proprietary format. As a result of analysis, 11 of 14 models have a customized subtitle stream. Subtitle stream chunk is TX, SB, ST, and AVI container. Also, GMHD chunk in AP4 container is subtitle stream chunk. This figure shows example for proprietary format. In this case, it is AVI container and TX and chunk size and sensor values. Dashcams generate not only multimedia files, but also other files. I'm going to give you 2 examples. One is text file that use NMA format. Our NMA file is created to record additional information about video frames for each multimedia container file. As shown in this figure, it allows examiners to identify metadata through interpreting NMA messages. The other is customized data file. It is proprietary format. We analyzed that, the structure as shown in the following figure. Some models record detailed operational event in our text-based log file. The log file shows the time and recording modes. In addition, various information is recorded. You can identify behavior of the device. Finally, the user preference file. Dashcams generally use standard format like SQLite and XML file for managing device information. So you can check this for product name and video quality and language settings value. This table that summarized our analysis result. As you can see, each model is storing a variety of metadata. As previously seen, metadata exists in various types, so we define a database schema for integrating dashcam metadata to efficiently store and manage dashcam metadata. Next, I will give simple 3 examples about using metadata. First, event reconstruction. It is possible to reconstruct dashcam-related events through a set of metadata that includes in timestamps when, why, where, and how. That is available in this figure. Second, abnormal detection. Multiple time values can be identified from multiple locations in a storage device. And as a result of analysis, these values are associated with each other. So it can be used for abnormal detection by using this rule. Third example is source identification. Source identification is one of research subjects based on unique characteristics. We considered the following, but there was a limited to distinguishing. Using folder hierarchy and file naming rules, it is difficult to distinguish multiple models from a same manufacturer. Using chunk sequence, two models have same chunk sequence, so that is impossible. Using watermark, it is hard to use watermark only to classify exactly all dashcam models. It is necessary to utilize combinations of multiple metadata for practically distinct dashcam models. Our future works studies will focus on deriving an efficient metadata combination for source identification. We have confirmed that various metadata are stored in dashcam storage device, but there is no tool to extract metadata. So we implemented a prototype based on Praso, and our implementation concept is like the following figure. In pre-processing, that is process of extracting data from image file, and in analysis step, that is interpreting and integrating data from Praso storage. We prepared a demonstration video. Okay, left screen is plus on Windows platform. First, extract multimedia data using by load timeline. And the process story is changed into SQLite by psort. And analysis step, filtering and interpreting and integrating data from process storage. When open the result file, we can see that the metadata has been extracted. Directory info and file info and metadata table and metadata source list for metadata table is joined. And it's your prototype code. This will require a lot of research in this future. So in conclusion, our research, dashcam is potential digital evidence that is explain the situation of a crime scene as a moving surveillance camera. In dashcam storage device, there are a variety of additional information. Various studies have been conducted for black box forensics, but most of them focused on extract and video frames. Our contribution is identifying metadata generated by 14 dashcam produced by 11 manufacturers, and proposing a normalized database schema to store and manage multiple different metadata. Introducing dashcam forensics activity using integrated metadata database, and also demonstrating the proposed concept through developing an open source tool based on Praso. Our research is enhancing visual data analysis by providing any additional resource. This research was submitted by IITP, and thank you. If there are any questions, I shall do my best to answer them.